Okay, so our next topic is going to be on the different types of compounds that we're going to take a look at. These are going to include ionic and covalent compounds. And what we're really going to explore is how we actually write these formulas and how we can write their names. So those are going to be our two big goals for this chapter, are writing formulas and writing the names of those compounds. And again, this is just what I reiterated, just so you know, we are writing formulas and then we're renaming compounds. The reason for this is essential for chemistry. If you don't know what a compound is, then you're going to have a really tough time in figuring out other stuff as we go through the rest of the year. So this is one of the most essential things that we're going to be covering this year. So first, we're going to take a look at these ionic compounds, which we've seen are created between cations and anions. And these bonds are very strong. Typically, we see them as solids at room temperature. They have pretty high melting points, and they are able to conduct electricity. Remember, they have these ions. Positive cations, negative anions create ionic compounds. Typically, we see these. If I go back for a second, typically we see these between positive cation metals and negative anion nonmetals. Our first type of ionic compound, these are called binary. The bi prefix means two, so it's compounds that contain only two elements. And so these compounds are only going to contain two different types of ions. So here are a few examples: MgCl2, NaCl, CaF2. Each of these only has two elements or two ions in each compound, whether it's magnesium and chlorine, sodium and chlorine, or calcium and fluorine. When we go to name these substances, we're going to write the name of the charged metal, or the charged cation, which is usually a metal first. It's always how we're going to do this. And then we write the first part of the name of the negative anion. The ending, though, is going to change to IDE. So the metal keeps its name. The non-metal anion piece, you keep the first half of the name, then switch the ending to IDE. So if we look at MgCl2, we keep magnesium, and then chlorine becomes chloride. We drop that INE ending for IDE. We also have sodium and oxygen combined together. Sodium keeps its name, but then the oxygen drops its ending to become sodium oxide. And we are going to be practicing this a lot. We can also go in the reverse direction. If you're given the name of a substance, you could figure out its formula. So if I give you the example of sodium chloride, we can look at it. We can note that it comes from sodium, which is Na, and chloride is chlorine, which is Cl. We know their charge is +1. Sodium is a group 1 metal. Chlorine's in group 17, so its charge would be -1. And these compounds are always going to try to be neutral at the end. So we want to balance these charges out, just as we've done with the Lewis dot structures. So for this particular formula, we just need one of each to balance. One sodium, one chlorine to create sodium chloride. Not always the case, though. Could take a look at calcium fluoride. Calcium has a +2 charge. It's in group 2. Fluorine is what stems from fluoride, has a -1 charge. These charges still have to balance, so what we would need are 2 fluorine ions to balance with the 1 calcium ion. So our formula is CaF2. And just as a check, 1 calcium is a +2, and each fluorine is -1 for an overall charge on this compound of 0. All ionic compounds use the simplest ratio of numbers. So in theory, Ca2F4 or Ca3F6 would also balance. They have the exact same ratio, but those can be simplified. So again, all ionic compounds, we use the simplest ratio of numbers, which in this case is 1 calcium with 2 fluorines. And an ionic compound The name of one of these is called a formula unit. So there's one formula unit for calcium fluoride being CaF2. So some tips for writing these formulas. Add the subscripts to the symbols of the two ions until the sum of the charges of the ions is 0. We end up using the smallest subscripts possible. So we reduce. And if there's only one atom of that element, you don't have to write a subscript. If it makes you feel more comfortable to write a 1 there, you can. But note that I'm not going to write the 1s. You're going to have to know that it means that there's 1 if there's no number written there. Now, there is a shortcut to writing out these formulas. If we know the ions and we know their charges, the charge of one ion is the amount of atoms that I need of the other ion, and vice versa. So we've seen this before. It's called the crisscross method. But here I'm just going to project it out. If I looked at calcium and fluorine, each with their charges +2 and -1, that means I need 2 fluorines for every 1 calcium. So again, note, I also didn't drop down the negative or positives with that. We can only have positive numbers of ions. You're never going to see a negative amount of calciums or a negative amount of fluorines. We don't have negative ions. We don't deal with that. And this should be a little bit of a refresher. We can predict the charge of our ions again based off their group numbers. Groups 1 and 2, group 1 metals are +1, group 2 are +2, group 13 elements become +3 in their charge. Groups 15, 16, and 17, we go -3, -2, -1. Remember, this is how many electrons that metals are either losing or nonmetals are gaining to end up looking like noble gases. They want a full valence shell of electrons, and they're going to do that the best way they can. So here are metals for groups 1, 2, and 13. One valence electron, they lose that one electron to get a charge of +1. And we can see it for groups 2 and 13 as well. As with our nonmetals, we get groups 15, 16, and 17. Group 15 elements they start with 5 valence electrons, so they need to gain 3. And as a result, their charge goes to -3. Group 16 starts with 6 valence electrons, so they'll pick up 2 to total 8 valence to go to a -2 charge. And group 17 goes from 7 valence electrons, gaining 1 to end up going to a charge of -1. So we are going to have to get pretty comfortable with these charges if we aren't already, because it's going to make our balancing and formula writing that much easier.